What we're going to do today is look into how to calculate the mean or the expected value of a random variable and the variance and standard deviation, along with some combining and some other things. So there's a lot going on, and I had PowerPoints for this, but I don't like them much. There's a lot of examples here, so let's just go for it. Let's just figure this out by doing examples. So we're on page 4, and this is the first example. You'll recall this from yesterday. X is the number of heads and 4 tosses of a balanced coin. All right, and that should look very familiar. All right, they want you to calculate the mean of X, and let's also just kind of make a little bit of a different notation here. That's the same as expected value. You can call it that, or you can just go mu of X, okay? So that's one way to, those are two ways to do it. Either way is great. So all you've got to do is take your value for X, each one. So we'll start out with 0 as the first one, multiply it by its probability, 0.0625, and then add the next value for X, 1, times 0.25, plus the next value for X, which is 2, times 0.375, and then plus 3 times 0.25, and then plus 4 times 0.0625. So what we've got here is just a weighted average, all right? So here are all your numbers that are weighted by their probabilities, okay? And we're going to end up with a value which shouldn't surprise you, because ask yourself, just as a matter of common sense, if you flip 4 coins, how many heads would you expect to get? And if you think 2 would be right, and that would be correct. Now, that doesn't guarantee you that if you flip 4 coins, you're always going to get 2. On average, 2 heads, but in the long run, you would, all right? And guess what this mean is? It's actually 2, all right? In a minute, I'm going to show you how to do this on a calculator, but that's what's happening here, all right? So we can scoot down to the next one, and we've got what is the mean size of an American household according to the following census data from the Census Bureau, and we've gone from anywhere from 1 up to 7 with associated probabilities. So this time, I think I will go ahead. Oh, and by the way, do you happen to notice that most of your probability is pretty well bunched on the low end? So let's start out. I'm just going to call this E of X, just to kind of wrap, just to be a little different. So that'll be 1 times 0.25 plus 2 times 0.32 plus 3 times 0.17, and you just keep going like that. All right, so we're rolling along. And if you are doing this the long way on your calculator, you're just going to have to be careful when you type it in. Get the pluses in the right place, the multiplications in the right place. If you do this, you get an average of 2.6, which is down here in this general range of numbers here, right? So why not? It seems like that's where most of the probability is anyway. All right, the next thing we want to do is just to calculate the variance, all right? So this is going to be, that's your symbol for variance. It's not the same like S squared, because this is not sample values. So we're just going to call this sigma squared of X, and that's going to be your value, your X value here. That would be 1 minus the mean, which you calculated over here. That would be 2.6 squared, remember you're in square units, times the associated probability of that. That would be 0.25, plus, now we'll go with the next X value, which will be 2 minus the mean, 2.6 squared, times the next probability, which is 0.32, plus, and then you go to what? The next one, 3 minus 2.6. It's minus 2.6 squared times 0.17 plus 4 minus 2.6 quantity squared times 0.15 plus, the next one is 5 minus 2.6 squared times 0.07 plus, and I'm going to come down here, the next one would be 6 minus 2.6 squared times its associated probability, 0.03, and then plus the last one, we finally made it, 7 minus 2.6 quantity squared times 0.01. And when you're all done with this, you should get that your sigma, or your variance, this is variance with the squared, is going to equal 2.02. So that's a measure of spread. Now you may want the standard deviation of that, which will just be the square root of your variance. So we'll just leave the square off of it. So that'll be the square root of 2.02, which is 1.42127. All right, I kind of went a little bit off the rounding, but remember it's at least 4. So there you go. There's your mean, there's your variance, there's your standard deviation. Okay, so let me show you what this looks like in a calculator, okay? So just trying to get my mouse going here. And I have all of those numbers input. They're all input. It's really easy to get this. All you got to do is go back to the home screen, pick up a calculator page, that would be here, and then just do what you might expect. It'll be menu, statistics, stat calc, and this is a 1 variable statistics. Number of list is 1. Okay, I know that you've got a 2 listed table, but this would be 1. All right, so your X list here will be X, and your frequency, let's delete this. We can make it go away. The frequency list will be probability. And we'll just tab down to OK. We'll hit OK. Now you're down at the bottom, you're not actually seeing what you want. All right, there's your 2.6. Remember that guy? And let's see, here is your standard deviation, right? Because it says sigma of x, not sigma squared. And you note that S of x, you know, our old friend for standard deviation, is undefined. Oh, a message. That's because your calculator knows that this is going to be like a population value. It's not from a sample. So there's no way to calculate a sample outcome from it. This is that sigma of x that we said we would use one day, and we never did use it, but now we are. All right. Now, if you want to convert this to variance, all you got to do is just take that number and square it. Now, it is a rounded number, but that'll be close enough. All right. So that's how you can do all of this busy work that you were seeing here that would be much easier to do on a calculator. And that's how you do it. All right. So now the last thing they want is the variance of the coin flipping thing that we did earlier on. So we'll call that sigma squared of x again. And that was 0 for the first x value. What? Hell, hold on. I'm thinking in terms of means. So let me start over. All right, so that would be x minus mu, 0 minus 2 squared, times the probability, 0.0625, plus, and then the next x was 1, minus 2 squared, times 0.25, plus 2 minus 2 squared. Now that term will go to 0, but I'm just going to leave it there, times 0.375, and then plus 3 minus 2 squared times 0.25, plus 4 minus 2 squared times 0.0625, right? And that'll give you, of all things, 1. So that's your variance. So your standard deviation, which would just be the square root of 1, will also be 1. So there you go. That's how you do that. So time to move on to another page. So I do need to pause for a second. So let me go ahead and do that. Okay, so back at it. We are now on page 5. And these are going to be rules for how to handle means and standard deviations in various contexts. All right. So you've got some formulas. You've got one here. You've got a couple here. I'm not super thrilled with those formulas, so let me add in my own here. I think these will be a little bit better. So if you're finding the mean of the sum of two random variables, that's just going to be the mean of the first plus the mean of the second. And if you're going to find the mean of the difference of a couple of random variables, that'll be mu of x minus mu of y. So it's very, very simple. And this will go pretty quickly. So the American Veterinary Association claims the annual cost of medical care for dogs averages 100. We'll call dogs X, just because they came first. Their medical care averages $100 with a standard deviation of 30, and for cats, the annual cost averages, we'll call cats Y. 120 with a standard deviation of 135. Suppose you have a dog and a cat, one of each. What is the mean of the distribution of annual veterinary costs for your dog and cat? And meaning, adding them together in this case. This is not probability. So mu of x plus y is just going to be, the mean for x is 100. And the mean for y is going to be 120. So together, that's going to be $220. Okay? So suppose you have a cat and two dogs. All right? If we have a cat and two dogs, that's just going to expand out the combining. This is going to be mu, and what do we say? Two dogs, that'll be x plus x, and then a cat, that would be plus y. All right? So that'll be 100 for the first dog and 100 for the second dog, plus 120 for the cat. All right? That'll be $320 average for all three. All right? So there you go. Combining means is super easy. All right, a linear transformation. All right, let me just, again, maybe put in my own formulas here. Maybe they'll make a little bit of sense. So the mean of a linear transformation, so I'm going to just put a plus bx. That is a symbol for a linear transformation. That's just going to be a plus b times mu of x. All right, so it's really, really simple. So the grades on a statistics test had a mean of 65. A curve was applied to the grade distribution, and here's the curve. Well, there's b and there's a. All we have to do is put in the original mean, and we'll get what we want. So the mu that we'll get from this will be 1.3 times the mean, which is 65, plus, or I guess in this case it's minus 4.5 plus a negative, and that will give you 80. So what that's going to do is transform that mean to a whole new mean. See how that works? All right, so there's your notes for means. Again, I've got to switch pages here, so pardon me while I pause. All right, so we're back. Now we're going to look for rules for variances. And we're going to combine two or more distributions either with addition or with subtraction. And I'm not super thrilled with that, so let me again put in my own. Again, we're talking variance, not necessarily standard deviation. So if we're going to do standard deviation, we're going to have to get to variance and then take the square root. So let's start out with the variance of x plus y. That's just going to be the variance of x plus the variance of y. All right? Now hold on, strap in, because this is going to kind of blow your mind. In fact, I'm going to change this to red. All right, the variance of x minus y. Are you ready? That's going to be the variance of x plus the variance of y. So it's plus in both cases. All right, that may seem like a little counterintuitive, but think about it this way. Let's just say I've got a distribution, and let's put it here, and we'll just call it distribution x. And I've got another distribution, I'll call it y. And so if I add the spread, you're going to get this spread plus this spread, all right? Now the thing is, if I then maybe call this line 0, and I scoot this over, and I put the opposite of y here, I know this won't be lined up perfectly, but let's just call this the opposite of y. All right, it still has spread, and x still has spread, whether y is down here or whether y is up here. So even if this is, consider this to be x plus a negative y, all right? So this spread and this spread will be additive, okay? So this is important to remember. With adding means, you do actually add them, and when you subtract means, you do actually subtract them. But when it comes to spread, all right, it's always plus. Always add the variances, all right? That's important. Don't forget that. So let me get rid of all this extra goopy stuff here. There, it's gone. Okay, so this is the same example, and we're just going to say figure out what the variance of the distribution of annual veterinary costs for your dog and cat. All right, so that'll be the variance of x plus y, which is just the variance of x, right? Now they're giving this in terms of standard deviation, so we want the variance, so that'll be 30 squared, and over here the standard deviation is 35, so we need that to be variance, so that'll be 35 squared, all right, and you'll end up with 2,125. Now I would put a dollar sign on this, but this is actually squared dollars. So if we were to take the square root of that, then we would get standard deviation, and that would be back in dollars. Okay, but this is only asking for variance. So suppose you have a cat and 2 dogs. Let's get the variance for that. All right, that'll be the variance of 1 dog plus another dog plus a cat. Okay, so that'll be 30 squared plus 30 squared plus 35 squared, and that'll give you 3,025. Again, that's in square dollars. If we want back into regular dollars, take the square root of it to standard deviation. So 3 cats and 4 dogs, yikes. All right, that'll be the variance of x plus x plus x plus x. You could call it 4x's if you want, plus y plus, let's get rid of that, y plus y plus y. All right, so that'll be 4 times the variance for dogs plus 3 times the variance for cats. And remember, the squaring only goes on the parentheses here. And that'll give you 72.75. Again, in squared dollars. Okay? Okay. Now, a linear transformation is going to be different. All right? And so up here, we were dealing with multiple distributions, 4 for dogs, 3 for cats, 2 for dogs, 1 for cats. But now we're just going to take one distribution and kind of mutate it or dilate it or whatever. We're going to transform it, just one. All right. So again, I'm not super thrilled with these guys. So let's go ahead and just say that this will be the variance of a plus bx of a linear transformation. Okay, the a is just going to be a horizontal shift. That will not change your spread, so you don't need that. All you really need is the b. So that becomes a formula b squared times your original variance of x. Okay? So the a, the shifting left or right, is not going to stretch or compress the spread. It's just the multiplicative part. Okay? So here, when we do this, we don't need the negative 4.5. This is just going to be our new variance is going to be 1.3, that's your b squared, times your original variance. Well, that's a standard deviation value, so that'll be 2.1 squared. And that'll give you 7.4529. Again, that is going to be your variance. If you want the standard deviation, just take the square root of that, 7.429. And what, 4529, my bad. Let's fix that up. 4529. And I don't have that number handy with me. I guess I could pop it out here if you'll be willing to just wait for a second. So, trusty calculator, square root of 7.4529. All right, that'll be 2.73. Okay? So, there you go. Now you got to memorize all these formulas, and you've got to be able to tell when you're combining multiple things, multiple distributions, and that doesn't require that b squared. Or if you're doing a linear transformation on a single distribution, that does require the b squared. So hang on, we're still rolling forward. All right, so on this one we have two tests and the results are independent. That's actually a kind of important thing, all right, when things are independent. It says combine the average scores and the variances. All right, well, they didn't give us variance. So if the standard deviation on test number 1 is 10, then the variance will be 10 squared or 100. And here, this standard deviation is 5, so the variance for it will be 25. All right? So we'll start out with the mean. The mean of mu of x plus y is just the sum of the two values. That'll be 30 for the first plus 40 for the second. That'll be an average of 70 for both, right? So there we go. The variance of x plus y, all right, that'll just be the variance of x, which is 100. We'll call this x and this y, all right, just so that we have something. In fact, let me just do this. We'll call this x, we'll call this y. And remember, this is just the variance of x plus the variance of y. All right, that'll be 100 plus 25, which is 125. All right, now there's a point here, and they're not actually asking for standard deviation, but let's go ahead and calculate it. All right, that'll be the square root of 125. And no, you don't add your standard deviation up, because if you were to add this up, that would be 15, correct? But the square root of 125 is not 15, it's 11.1803. So never, never, never add standard deviations. Go to variance first, get the combined variance, then come back to standard deviation. So there's your variance, and there's your standard deviation. Okay? Very important. All right. So for this one, it says for test number 1, double the scores and add 5. Maybe we can look up here. And for test number 2, triple the scores and subtract 45. What are the new means and standard deviations for both? So let's start out with mu of 2x plus 5. That'll be your original mean, which is 30. You double it, and you add 5. So that'll be 65. All right, so now the variance, remember you have to go through variance first, of 2x plus 5. Okay, you don't need the 5, right? You only need the 2 because we're modifying a single distribution here. So this will be 2 squared times your original variance, which is 100, or 10 squared, whatever. And so that's 4 times 100, which is 400. Now to get the standard deviation for 2x plus 5, that'll just be the square root of 400, which is 20. So there's the 2 things they want. That's for the first test. All right? So the next one will be mu of 3y minus 45. That's not right. So minus 45. So you triple your original. That would be 3 times 40. And then subtract 45. So that's 120 minus 45, which is 75. There it is. And then to get your variance of 3y minus 45, again, you don't need the 45. That'll just be 3 squared times your original variance, which will be 25, or 5 squared, whichever. And that'll be 9 times 25, which is 225. And so your standard deviation of 3y minus 45 is just the square root of that. All right, and that'll give you 15. All right, one more to go. So just absorb as much as you can. We're going. So let me go ahead. Where are you guy? Here you are. All right, this last one on page 8 has 2 distributions. This is student questions received by email for a professor. And they've got ones for the day, received during the day. And then there's some that are received during night. So this is random variable x. This is random variable y. All right, I put these in the calculator. So this is what I ended up with. Let me scoot this up a little bit. So during the day, mu of x. All right, and again, I just did this in the calculator, was 2.95. Now the calculator gave me the standard deviation. All right, so standard deviation of x, and I'm going to do this out to all the places it gave me for accuracy. So through 1.32193, and I just went ahead and squared that to variance because they asked for it. Okay, and that gave me 1.7475. All right, so those are those 2 things, and then for the night, scroll this up. I did those again on the calculator. So mu of y, the average I had was 0.49, so about half an email. The standard deviation was 0.741552. And so I squared that to variance, and that gave me 0.549899. All right. So then it says, well, let me box in what they wanted just so we can be clear on what they asked for. So then they want the mean and standard deviation for x minus y. All right. All right. So let's do mu of x minus y. That's really simple. That's just going to be 2.95 minus 0.49, and that'll give you 2.46. All right, so we have that. Now don't subtract the two standard deviations, all right? We've got to go to variance. And remember that even though this is a difference, you have to add them, all right? So that'll be 1.7475 plus 0.549899. All right, that'll give you 2.2974. Okay? And so the standard deviation will just be the square root of that. All right, so the square root of that, let's see, we'll write it all out. 2.2974. And that will give you 1.51572. All right, so make sure you don't mess up on that. And make sure you don't mess up by trying to add this to this. You've got to go through variance first. Okay? Couple of real easy ones, and then we'll be done. It says, what is the probability that the number of emails received during the day is beyond one standard deviation from the mean value? This is not normal calculations. They didn't tell you things were normal. So all you got to do is just, this is during the day, so it's a random variable x. Take your average for x, your expected value, and add a standard deviation to it. All right? And so that will give you, what was it, 2.95 plus, and let's look up here and make sure, 1.32193. And this will give you a value of 4.27193. And we want to know the probability that x is greater than that. So just go up here, and we're looking for anything above 5. Or, yeah, after when 5 starts. So that should be 0.1. So this is what we're looking for right there. So your answer is 0.1 or 0.10. And finally, if it takes the professor an average of 10 minutes to respond to each email, how much time should the professor expect to spend responding to student email? Well, here is the expected emails during the day. So if he gets, on average, 2.95 of them, almost 3, we'll just multiply that times 10 minutes. He should expect to spend 29.5 minutes. Or what, 29 minutes and 30 seconds, looks like. So there you go. That's it. That's it for notes. So try your homework. Remember that there were some problems added on at the end. It didn't end where the original calendar. It should be posted in the room, and it's also up on Canvas. So anyway, I hope that you learned a lot. This is interesting, and it's kind of fun. Just practice it and make sure you get it down well. So with that, I'll bid you a fond farewell.